All right, this is by request. Let's see. First of all, oh yeah, this is the Benini part. That's not in the circuit. That's just mounted to the board there. You can see the strobe effect from the LED. There's the 555 pulse shortener circuit that I just posted the schematic of. It's starting to look a little ridiculous here with the boards chained together like that, but I didn't have any more of the circuit boards, so I just built that one with wire wrapped wire on directly onto a socket, and then that's the tantalum timing capacitor, and that's the LED dropping resistor, and so then there's the LED wires there. So this did a good job of shortening the output pulses from the 4017, which is dividing by 4 the output pulses from the op-amp comparator. I still don't know how you pronounce that. Anyhow, so there's that. Now, it's running along just fine, and if I take and go onto here, and if I turn this pot, you can see that I'm turning it counterclockwise now and clockwise now. Okay, and if you look at the neon, you can see that the neon also, the brightness of the neon or the intensity of the spikes is also controlled by varying this duty cycle through its range there. Now, to my eye, the strobe lines there are steady. What you're seeing is actually a camera aliasing effect. And we just restarted the 417 or 4017, and now we're looking at the 1. You could put a marker out here for where that line should appear when you're at the optimum dwell timing situation. And actually for this setup, it's about there. Okay, now on the scope screen I have the top trace is the output from the 4017, and the bottom trace is the output from the sense coil, or the input to the, I'm sorry, not the 4017, but the op-amp. So this is the gate signal to the MOSFET up there on the top trace, and the bottom trace is the output from the sense coil, or the input to the op-amp that's producing that trace as the output. Okay, and since that's the gate signal, high is on for the MOSFET, and that's right, because you want the whenever the voltage crosses over the 6-volt line on the sense coil, get that little 1-volt or 7-volt pulse, that's when you want the thing to turn on. Now I'm going to vary that pot again, turning it clockwise. Now you can see the rotor starting to slow down, and let's see, that's the shortest on duty cycle. So now I'm turning it back counterclockwise. Now we're getting acceleration. Still turning counterclockwise. Now that's 100% on, and so of course we're not driving the rotor anymore. So turning back counterclockwise. Look, oscillations. Oscillation. You see those? See the magic Ainsley oscillations in there? Okay. So somewhere around 60 or 75%, I think, is about where this one runs the best. Now you can see it accelerating. All right. I hope that's what you wanted to see, and thank you for watching.